All right, class, let's go ahead and look at section 2.7 today. And section 2.7 today is called problem solving, and we're dealing with consecutive integers. Now, first thing I need to point out, number one, if we're doing problem solving, okay, that's got to be the 5-step plan, okay? And we've spent some time, a lot of time, getting that down when we were in chapter 1. Now, the second thing we need to look at is this idea of consecutive integers. So, if you look, Mrs. Burton gave you a note sheet today to kind of help us. So, what does that word consecutive mean? What do you think consecutive means? Nice. One right after the other, okay? In a specific order, sequence, a lot of good wisdom coming from students in this room telling me what they need consecutive integers are. Who can give me an example of consecutive integers? Yeah, 4, 5, 6. How about if we went on the negative end? -2, -3, -4. So all of those are examples of consecutive integers. Now, we need to know, okay? Now, if consecutive integers then, if we're working with consecutive integers, what are we counting by? When I go from 1 to 2, what did I add? Yeah, we're going to see that when we're talking about consecutive integers, we're counting by ones. Now, the second thing we need to look at is this idea of even numbers. Now, if I was talking about even numbers, what are even numbers? Yeah, 2, 4, 6, 8. Good job. And then what are my odd numbers? 1, 3, 5, 7. Nice. So we've got evens and odds, but sometimes they want even and odd consecutive integers. Now, let's think about that for a minute. If I'm dealing with even numbers, okay, when I go from 2 to 4, what are we counting by? Yeah, 2 plus 2 is 4. What's the next even number? 6. 4 plus 2 is 6. So we're counting by 2s. All right, we're counting by 2s. Now, this is going to surprise you, but the same thing holds true if I'm looking for odd integers. When I go from 1 to 3, what am I counting by? Yeah, 1 plus 2 equals 3. Okay, 3. What's the next odd number? 5. How did I get there? 3 plus 2 is 5. So, whether we're doing evens or odd integers, we're counting by 2s. Now, let's practice a little bit on how to represent these integers by using an expression. It says an integer is represented by n. So, let's look at letter A. For letter A, write the next 3 integers in natural order after n. So if the first integer is n, what do you think natural order means? Yeah, one right after the other are consecutive. And so if my first integer is n, the second integer has to be, n plus 1. It's just the next number in line, so we're counting by ones. If n plus 1 is the first, what's the next one? Yeah, n plus 2, and then the third integer after n would be n plus 3. Nicely done. Now, let's look at my letter B. Letter B says, write the integer that immediately precedes n. Who knows, what does precede mean? Yeah, precede means the one before. So how would you give me an expression to tell me the integer that comes before n? Yeah, nice. It would be n minus 1. Now, let's look at letter C. It says, write an equation that states that the sum of 4 consecutive integers starting with n is 66. So we need 4 consecutive integers. What does consecutive mean? One right after the other. What are we counting by? Ones. So the first integer is n plus the second integer, n plus 1, plus the third integer, n plus 2, plus the fourth integer, n plus 3, Ooh, what does is means? Equals 66. Okay, so now I'm going to tell you, consecutive integer problems are a big deal. They're almost always on those spring SAT questions or ERB tests. Okay, they're on college entrance exams. So it's a big deal to know how to take care of consecutive integer problems. So let's go over here and look at my first slide. I want us to write an equation to represent the given relationship among integers. Now it says, remember to define your terms. So we're going to go and we're going to use our 5-step plan up to the equation part. So we only need to do the first 3 steps, kind of like when we were in section 1-6. So if I'm working on the question number 1, step number 1, it says the sum of 3 consecutive integers is 39. Okay, now I'm going to go ahead and box is because that's the first thing we do. So what are we looking for? Step number 1, we need 3 consecutive, integers. Okay, now because I need 3 consecutive integers, guess how many let statements I need? You got it, we need 3 let statements. So the first let statement on a consecutive integer problem is always n. Let n equal my first integer. Now, we're going consecutively, so that means we're counting by ones. So my second integer is going to be n plus 1. That's my second integer. And guess what my third integer is going to be? Right, n plus 2 is my third integer. Nicely done. Now, we need to take these let statements to create step number 3, which is my equation. The sum. What does sum mean? Yeah, we're going to add them all up. So we need to take our let statements, the first integer plus the second integer plus the third integer is means equal 39. Okay, now chew on that for a minute. Does it make sense? Yeah, it does. Okay, again, long and drawn out, but it's pretty simple once you figure out where we're going. So let's go ahead and do my next problem. It's number 6 on your worksheet, but let's look at it. Okay, so it says the sum of 3 consecutive even integers is 72. So this time, if I'm looking at step number 1, what are we trying to find? Well, it's written right there. What are we looking for? 3 consecutive, you're going to get real good at spelling consecutive even integers. Okay? Step number 2, let statements. How many let statements do I need? Yep, if they want 3, I need 3. So I'm going to let n equal my first integer. Now, did you notice this time they wanted consecutive even integers? What are we counting by if we're looking for even numbers? Nice, somebody remembered. So n plus 2 is my second integer. And then what's the third integer going to be? N plus 4. Nice. That's my third integer. Okay, so we've got step 1. We know what we're looking for. Step 2, we've got all of our let statements. So now let's write our equation. Step number 3. What's our operator word? Yeah, sum. So we're going to add up all of our integers. We're going to add up all of our let statements. So the first integer is n. The second integer is n plus 2. And the third integer is n plus 4. And their sum is 72. Nicely done. Okay, let's look at number 12. Okay, so the product of 2 consecutive odd integers is 195. Okay, so step number 1. What are we looking for? 2 consecutive odd integers. There we go. 2 consecutive odd integers. Okay, step number 2. Who remembers? That's right, my let statement. Okay, how many let statements do I need? Yeah, we need 2. What's the first let statement when we're doing consecutive integers? Always and forever. Let n equal the first integer. I'm going to go across this time. I'm running out of room. And we're going to let n plus, okay, remember it was odd integers this time. What are we counting by if we're doing odd integers? Yes, good job. N plus 2, I changed the inks on me, is my second integer. Nice. Okay, so now we just need our equation. Do you see our operator word? They changed it on us. It's product. What does product mean? Product means multiplication. Mrs. Burton forgot the box is. Now, it's better to write product when we're dealing with these as distributive property. So we've got n times n plus 2 is means equal 195. Now, just a little side note. Here's why. If you wrote n times n plus 2 equals 195, if you looked at that following order of operation, we just do n times n and then we'd add 2. So that's why it's very important to make sure that you use your distributive property when we're doing these consecutive integer problems. Nicely done. And it's kind of repetition of a theme as we go through and take care of each one. All right, now, let's look. Write an equation to represent the given relationship among integers, then solve over the given domain. Oh, they're giving us the domain. What does that mean? Yes, that means I need an input-output chart. Okay, but story problem means 5-step plan. So step number 1, what are we solving for? It says the sum of, here we go, 3 consecutive even integers is means equal, okay, 30 more than the largest, okay? Again, we still got to be good dissectors. So step number 1, what are we looking for? Well, it's right there. 3 consecutive even integers. Okay, that's what we're solving for. Okay, step number 2, let statements. How many let statements do I need? 3. So I'm going to go ahead and just pull this up because I've already got it written all out. So here's let statement number 1. X is my first even integer. X plus 2 is my second even integer. I'm taping, if you can wait. Thanks. Okay. Oh, sorry about that. Okay, and then n plus 4 is my third integer. All right. So now, here's my equation. Here's where you've really got to pay attention. The sum of 3 consecutive integers. Do you see here's the sum? There's my sum of 3 consecutive integers. I just took all 3 of my let statements and I added them together. Is means equal 30 more than the largest. Now, 30 more, we know that means plus 30, and then we need the let statement for the largest, which was x plus 4. So does that make sense to everyone? Okay, now we've been getting through steps 1, 2, and 3, so now we've got to go to step 4. Now remember, step 4 is my input-output chart. Because they gave me the domain right here, all right, I've got to set up an input-output chart. So here it is. Now, if you notice, I kind of do my input-output chart a little bit easier when I'm dealing with my consecutive integers. So we're going to start with 14. So 14, and then 14 plus 2 is 16, and 14 plus 4 is 18, equals 18 plus 30. Okay? So we're going to go through, and that's actually, that's true. I do the same thing for 18 and 20, and they're both false. And so now I've got to answer the question. Now, the question was 3 consecutive integers. So when you get true at 14, you just found n. You just found one integer. What are the other two? Well, 14 plus 2 is 16, and 14 plus 4 is 18. So 14, 16, and 18. So make sure you answer the question. And then for step 5 on this one, for the check, I just let you put a check by your true statement. Makes it a little bit easier since we have so much work to do. All right? Okay, now we need to try 2 together. And we're going to do this a little bit fast. Here we go. So here's the first problem. We'll make this problem number 1. Okay, the sum of 3 consecutive odd integers is, 32 more than the smallest. Okay, and here's my domain. Now, I'm going to go to a different slide because we need to get all of this in here. So step number 1, we need 3 consecutive odd integers. Okay, step number 2. Okay, that's my let statement. So let n equal the first integer. Now we need odd integers, so what are we counting by? Nicely done. N plus 2 is my second integer. And then n plus 4 is my third integer. Okay, and now we're on step 3, the equation. Now let's go back here and look at it. The sum of 3 consecutive odd integers is. So we're just going to add these guys up. Okay, so the first integer is n, plus the second integer, plus the third integer is, and then what did it say? 32 more than the smallest this time. What let statement goes with the smallest? And that's just n. Okay, everybody see what we did? Nicely done. Now, let's everybody take care of their input-output chart. Miss Burton didn't leave herself enough room, did she? She wrote too big. Okay, equals 32 plus n. And remember, the last line is whether it's just true or false. I forgot our numbers. What were our domain was 9, 11, and 13. 9, 11, and 13. Okay, let's try it. So we've got 9, and 9 plus 2 is 11, plus 9 plus 4 is 13, equals 32 plus 9. So let's figure it out. That's 20, 33. 33 does not equal, what, 41? So that one's false. Let's try 11. If we plug in 11 plus 13 plus 15 equals 32 plus 11. So what do we have this time? We have 10, 20, 30, 8, 39. I think that's right. 39. Well, 39 does not equal 43, so that's false. So let's try 13. So we've got 13. Okay, 13 plus 2 is 15, and 13 plus 4 is 17, equals 32 plus 13. So we've got 17 and 13, that's 30, 45. So we got 45. Hey, guess what? Equals 45. There's my true statement. That's my check. So now, what are my 3 consecutive integers? Well, they would have to be what? The integers are what? 13, 15, and 17. Now, nicely done. Long and drawn out? You betcha. But that's how we get through a consecutive integer problem. Now, we're just going to take the time to break apart the second problem here so you can see how we busted up to get our equation. All right? So, find two consecutive integers, okay, whose product, there's my operator word, is, 4 or less than 4 times their sum. Okay? All right, let's see. So I need two consecutive integers. So let's go over here and let's try it. Okay, so step number 1. We need two consecutive integers. Okay, step number 2. Okay, two consecutive integers. So we're just doing consecutive. So that means I need two let statements. So let n equal the first integer, and n plus 1 is going to be the second integer. And now here comes the hard part, step 3. Okay, let's look at it again. Find two consecutive integers whose product. So what do they want me to do with those two integers? Well, product means multiplication. So we're going to say n times n plus 1 is, what's the back part say? 4 less than 4 times their sum. Now, why did Mrs. Burton put a heart around less than? Yeah, order matters with subtraction. So I know we're going to have minus 4 somewhere, and then 4 times their sum. Well, their sum means we're going to add them together. So we've got n plus 1, and we need 4 times that. Does that make sense? Okay? Two consecutive integers whose product is 4 less than 4 times their sum. Okay? And then after this, you would just do your input-output chart. So what were our choices? We had 0, 7, and 11. 0, 7, and 11. That's n, and then n times n plus 1. Okay, and again, what do you think what might be wrong if you got 3 falses in your input-output chart? Yeah, probably means you might have made them, you either got the equation wrong or you did the math wrong. So let's try these. Let's try 0. So we've got 0 times, 0 plus 1 is 1, equals 4 times 0, 1 minus 4. So let's check that out. Hey, guess what? This is going to give me 0, and 4 minus 4 is 0. Does 0 equal 0? Yeah, that's a true statement. Let's try the 7. We've got 7, and then we've got what? 7 plus 1 is 8, equals 4 times, we've got 7 plus 1 is 15 minus 4. So 8 times 7 is 56. 4 times 15 is 60. Is that right? Yeah, 60. 60 minus 4 is 56. Oh, wow, we got another true. Let's try 11. We've got 11 times 12 equals 4 times 11 and 11, 22, 23 minus 4. What's 4 times 11? 132? Okay, and then there's no way that's going to work, so it's false. Okay, so guys, here, look at this. Did you realize we had 2 trues this time? That can happen, but they want me to tell them 2 consecutive integers, so you get to choose. If you want to choose 0, then you would say the integers are, what, 0 and 1, okay? Or you could choose the 11 and say the integers are 11 and 12, okay? But you could not say 0 and 11. Why is 0 and 11 not the right answer? Right, because they're not consecutive. They gave you true statements. Both of them gave you, you know what Mrs. Burton did? I said 11, and that was false. It should have been what? It should have been 7 and 8. Sorry about that. Okay? All right. So again, I could say 0 and 1. I could say 7 and 8, but I cannot say 0 and 7. Why? Because they are not consecutive. Now, I know that was a long lesson, okay, but a very important lesson for you to refer to tonight as you do homework.